All right, it should be playing. Okay, so first one, we are looking at the classifying a triangle. So classified triangle means that we want to give it its name. So the first one that you're going to have to do is use Pythagorean theorem. Now we said that if c squared equaled a squared plus b squared, then it was a right triangle. Now when you don't have to copy everything down, but I would write down any work, maybe any pictures that are on there. You don't have to write the whole problems out or anything like that, but take notes on the things that I'm doing and maybe draw a quick diagram if you can while we're doing it. If c squared was greater than a squared plus b squared, we said it was obtuse because c squared was bigger than the other two, means the angle was bigger, makes an obtuse angle. And then if c squared was less than a squared plus b squared, it was acute. It was an acute triangle. And the angle would be smaller. So they gave you 4 triangles. So you would take the first one, your A and your B are always the smaller 2 numbers, and C is your biggest number. So you would do something like 26 squared, and you would want to compare it to 7 squared plus 24 squared. So 26 squared is, I think, 676. Yep, 676. And then 49, 24 squared, I think, is 576. Yep, 576. And when you add 576 to 49, you get 625. So 676 is greater than 625, so this first triangle would go in the obtuse category. Okay, this one would be obtuse. I'll do like 1 or 2 more here. If you did the second one, you would do 17 squared, and you would compare it to 8 squared plus 15 squared. And 17 squared is 289, 8 squared is 64, and 15 squared is 225. And when you add 64 and 225, you get 289. So those two are equal, so this one would have been drug into the right triangle category. Because c squared was equal to a squared and b squared. And that would make it a right triangle. That's when the Pythagorean theorem works. When it works, it's always a right triangle. If you did the third one, 17 squared is 289. 13 squared plus 15 squared, you'd have 169 plus 225. So if you do 169 plus 225, you've got 394. That's a really big number compared to 289. So this time the c squared is less than a squared plus b squared, so it has to be in the acute category. So, and you can see the last one was also a right triangle. So from the answers there, it was a right triangle. So that's how you did the first one. Like I was saying, just write down any little work and any pictures that are on there you would want to write, and maybe any notes. And I can come back to this one if you need it. So I'm going to move on so we can keep the video rolling. All right, number 2. They're giving you an altitude from the right angle to a hypotenuse. We went over that section in the very beginning, and I said that this number, this altitude, we call the geometric mean between those 2 numbers. Geometric mean. And that means that that number is going to be in the 2 mean places. Whatever this line is, it might be a number, it might be a variable, but whatever it is, it's going to be in the 2 mean spots. The 2 numbers that get broken up into on the hypotenuse are your 2 extremes, 15 and 6. Now, do I have to put 15 on the top and 6 on the bottom? No, I could switch those 2. You're still going to multiply them anyways. You just have to make sure that these 2 numbers are in these 2 places. They have to be in those 2 spots. Doesn't matter which ones. X times x will give you x squared. 15 times 6 will give you 90. And when you square root both sides, and you look and it says exact value, you're going to leave it as a radical. Radical 90 would work, but it's just not your best answer. Your best answer would be to take a 9 out. Radical 9 times radical 10. The reason I say take a 9 out is because that's a perfect square. So your best answer is 3 radical 10. Radical 90, I believe, would still be right. It's still an exact value. It'd still be an exact number. So that was number 2 on the test. Your number 2 will probably be real similar to that. Like I said, just draw a quick diagram for each one, and then maybe just the work, and move on. So that's how that. So that way you'll know how it works for each one. All right, moving on. Number 3 here. Okay, so here you've got 3 triangles that they want you to put in order, but they want you to order them by the tangents of angle A. So draw your 3 little quick diagrams first and circle angle A in all 3 of them. So those are the angles that you want to find the tangent of. And again, if you guys miss anything, it'll be on the video. You can just go back to the video and watch it and fill it in later if you need it. But circle angle A for all 3 of these. Now, if you remember your SOHCAHTOA, S-O-H-C-A-H-T-O-A, we're looking at the TOA one because it says tangent. So the tangent is your opposite side over your adjacent side. Basically, those are the 2 legs. Opposite and adjacent are always the legs. So you're going to take your opposite leg, put it on top of your adjacent leg. So the tangent of this triangle is 20 over 14. And if I want to put them in order, then I'm going to make that a decimal. I'm going to take 20 and divide it by 14. And that's going to give me 1.43. So 20 divided by 14, because it's going to be 20 is your opposites. 20 is opposite, 14 is adjacent. O over A gives you your TOA. And I can actually put tangent of A here equals 20 over 14. And you get 1.43. Here the tangent of A would be opposite over adjacent. So here the tangent of A is 8 over 8. So that's an easy one to divide. That's just a 1. And then here your opposites and your adjacents would be tan of A would be 60 over 51. So 60 divided by 51, you get 1.18. So it's 60 over 51. Make sure that looks like 1. Okay, and that would be 1.18. So which one would be at the top of your list? The smallest one is that middle one, right? This is the smallest one. Then your middle one would be this one right here, and then your biggest one would be that one right there. Not the size of the triangle. All they want to know is which one has the smallest tangent, which one has the next smallest tangent, and which one has the biggest tangent. That's all it's asking them. I'm just dividing them because they wanted that one fraction, that's all. That's the only one they wanted. Now, when you get your test, you might be asked to do the value of sine or the value of cosine. Okay, so you just find all the sine values or find all the cosine values. Okay?
Miss Roback, is this still on campus? Can you please dial the switchboard? Miss Roback, please dial the switchboard.
Okay, for the next one, you've got, it says give the value of each trig ratio. Okay, so that means we want the sine m, we want the cosine of m, we want the tangent of m. We want the sine of n, we want the cosine of n, and we want the tangent of n. Okay, so you want all 6 of these trig functions. We don't do p because p is the right angle. We only do the m and the n, the 2 acute angles. And if you remember your SO, S-O-H, CA, C-A-H, T-O-A is TOA, you should be able to get all the 3 sides with no problem. So if I'm starting with m, if I circle m, then this is my opposite side. This side down here is the adjacent side because my right angle box is here and across from it's always my hypotenuse. So those are the 3 sides if you're using m. And if I'm using sine, I want the opposite and I want the hypotenuse. The O is the opposite, H is hypotenuse. So sine of m would be the opposite 32 over the hypotenuse 68. 32 over 68, and I would divide that by 4, and I would get 8 over 17. That would be the sine of angle M. Cosine of M is the adjacent 60 over the 68. 60 over 68. Again, I would divide by 4 and get 15 over 17. And then the tangent is the TOA, T-O for opposite, A for adjacent. You want 32 over 60. This one I would divide by 4 and get 8 over 15. So that would be the sine, the cosine, the tangent of angle M. Now what happens when you go up to N though? What changes if you go to N? Opposite becomes the adjacent, and the adjacent becomes the opposite, but hypotenuse doesn't change. That stays. That's always the same. So if I'm at N, my opposite is 60. My hypotenuse is 68. 60 over 68. You can see that the cosine of M is the same as the sine of M. They're both 15 over 17. Cosine is going to be the 32 over the 68. So that's going to be the same as the sine of M. That's going to be 8 over 17. And the TOA, the tangent, is just going to be its reciprocal. It's going to be 15 over 8. When you reduce them, it's going to just be 15 over 8. So that's all they were looking for. You just had to drag it into the right box. That's all they wanted you to do on that. Drag it into the right box. All right. I think that's 4 or 5. That was 4? All right. Moving on. They go faster. Like this one's super easy. Sine of 81 is going to be the cosine of its complementary angle, so that's going to be 9 because these two together have to make 90 degrees. Complementary angles. Cosine of 9 is the same as the sine of 81. Those are complementary degrees. As long as they add up to 90 degrees, then the sine will be the same as the cosine of those two angles. So that was right, sine of 81 in terms of cosine. This one they wanted us to find out which trig ratios are true. So you can see the two that are highlighted are true, but let me show you why. All of them have 40 degrees. Okay, all of them have 40. So here's your 40. Here's your opposite. Here's your adjacent. Crossing the right angle is always your hypotenuse. So I would take the sine of 40 and just say it's going to be x over b. And I'd see if that was one of my choices. If I look at it, sine of 40 is not b over x. There it is right there. That's one that works. Then I would do cosine of 40. Cosine of 40 is a over b. A is adjacent, b is hypotenuse. Adjacent over hypotenuse, AH. Cosine of 40 is not x over b, and it's not a over x. So none of these are right, and that one wasn't right either. And the last one I would do is tangent of 40. It would be the opposite over the adjacent. It would be x over a. X over a, so let's see if they put that one, and they did. The bottom one was x over a for tangent. That one didn't work, that one did. So you would just have the triangle, find the 3 trig functions, and then compare them and see which ones are there. That's all you're looking for, which ones actually showed up. So that was 5. 6 is the area formula. If you remember, we had this area equals 1/2 times A times B times the sine of C. As long as you had an A, a B, and a C somewhere. You could have a B and a C here, but then this one would have to be A. So you might have B, C, sine of A. As long as an A was present, a B was present, and a C was present. So if you look at what they gave you a B, they gave you a C, and then they gave you an A right there. So you have all 3 letters. So let's plug in what we have. We're going to put area equals 1/2. We're going to be using B times C times the sine of A. So that's going to be 1/2. B is 6. C is 17. And we're going to multiply that by the sine of 135. And that's just a put in your calculator and multiply problem. So I would take 1/2, which is 0.5, times 6 times 17 times